Michael had ducks and cows on his farm. One day he counted them in a strange way. He counted 54 heads and 134 feet. How many cows? How many ducks? This picture is going to help us figure out this problem. We have 54 circles here, and let's make some of them ducks, and we'll see how close we are to our solution. A yellow circle is going to be a duck, so let's make this first whole section ducks, and then we'll see how close we are. When you draw a picture, it's kind of like the guess and check method. So that's 13 there and 13 there, so that's 26 ducks. 26 times 2 is 52. And if we had 54 animals and 26 of them are ducks, then that leaves, let's see, 14, 4, it makes 28 of them cows. So if 28 are cows and cows have 4 legs, 2, 3, 112 plus 52, that's 4, 6, 164. And we want to go to 134. So that's too many legs. So if we increase the number of ducks, then we reduce the number of legs. So let's add some more ducks onto this. Let's see, 164 is actually 30 more legs than we need. And cows have twice the legs of ducks. So if we add 15 more ducks, it should give us close to the right amount. So there's 15 more ducks. So we had 26 ducks, we added 15. So let's clear off this other spot and then we'll keep working and see how close we are. So 41 ducks, 41 times 2, and that leaves 13, because 13 plus 41 is 54. 2, 52, and 2, 82. 82 and 52, 434. So that's the right amount. So ducks equals X, and cows equals Y, and there's 41 ducks and 13 cows. As you can see, this picture is about the same as this guess and check method. So we could say that there's 30 ducks, and then that would equal 24 cows. The duck feet would be 60. 24 times 4 is 96. 96 plus 60, that's 156. So that's high. So we would want to increase the number of ducks to reduce the number of feet, hooves. So if we increased it to 35, then that would make the number of cows 29, because 35 plus 29 should be 54. Let's double check that. 35, 29, 14. It's going to be 64, so I went wrong somewhere. Oh yeah, this should be 19, not 29. 35 plus 19, 54. Okay, so 35 ducks will have 70 feet. 19 cows will have 19 times 4. It's going to be 6, 3, 76. And that's 70 plus 70 is 140, plus 6 is 146. So we're still high, but we're closer. Now we already know the solution is 41 ducks and 13 cows because we figured that out. But this method here using this table would also be useful for us. The next method we'll look at is graphing. The first thing you want to do is write two equations from the story, and you can use the chart from the guess and check to help you. But you know that you have two totals here. 54 is one of your totals, and 134 is your other total. You know that X equaled the ducks, and Y equals cows. And you know that the number of ducks plus the number of cows equals 54. and that ducks have 2 legs and cows have 4. So these two equations will help you graph, and then you can figure out the solution. Both of these equations need to be written in slope-intercept form. So x plus y equals 54. We need to subtract x from both sides. So we have y equals negative x plus 54. And then this bottom equation, we need to subtract 2x from both sides. So 4y equals negative 2x plus 134. Divide both sides by 4. So y equals negative 2/4 x plus 134 divided by 4. It's going to be 3 and 12 and 1 and 4 and 3 again. 12, 2, 0, 33.5. And this equation, the slope here can be simplified. So it should be y equals negative 1/2 x plus 33.5. This equation here can be graphed, as well as this equation here can be graphed. Y equals negative x plus 54, and then y equals negative 1/2 x plus 33.5. Remember your slope-intercept form, y equals mx plus b. You got your y-intercept here, here, and here. So the first equation, we have a y-intercept of 54, and that point is here. I'm trying to make it larger so you can see it. And then we've got slope, which is here, here, and here. The slope of the first equation is actually negative 1/1. So down 1/1. For this graph I made on my graph paper, I made dots at every intersection there, going down 1/1. And then I lined up my ruler very carefully along the dots, and I drew my line. And you can see here that the point of intersection is 41, 13. Here's 13, and here's 41. Just to show you again, 33.5, I made that dot right here. But you can imagine some of the difficulty with this graph. If you have to have 54 as a y-intercept, then you need to have a very large piece of paper. And then as soon as you start introducing decimals into your graph, the chance of making a mistake increases because it's more difficult to work with decimals on a graph. So graphing works for this, but it may not be the easiest method. Let's take a quick look at Desmos. Desmos is a really cool free online tool. You can graph anything on it. Put your equations in there in slope-intercept form. So we had y equals negative x plus 54. And we also had, let's see, y equals negative 1/2 x plus 33.5. So I put in the equations in slope-intercept form, and then zoom out on your graph. Can you see how small it is though? If you had to do this on a regular piece of graph paper like I showed you, it's kind of tricky because 54 is a pretty large y-intercept. If you were just drawing this graph in your notebook, it would be very hard to do it accurately enough. So here is our point of intersection, and the point of intersection, let me zoom in on it, is 41, 13. Okay, let's take a look at the other two methods that we're going to check out today. Substitution. Convert the simpler equation into slope-intercept form. So we know we had two equations, x plus y equals 54, and 2x plus 4y equals 134. So this equation is our simpler one, so convert it into slope-intercept form, and we've already done that. Y equals negative x plus 54. And then it says to use what you know. You know that y equals mx plus b. You know that this chunk right here has the same value as the variable y. So you're going to take this highlighted piece and you're going to substitute it into the other equation. The other equation was 2x plus 4y equals 134. But again, this y we're going to substitute for this here. So we have 2x plus 4 times negative x plus 54 equals 134. Distribute your 4. So you have 2x plus, nope, not plus, it's going to be minus 4x. And then 54 times 4, 216 equals 134. Combine your two like terms. So 2x minus 4x is actually negative 2x plus 216 equals 134. Now we subtract 216 from both sides. 216 minus 134. 2, make that a 1 and an 11, make that an 8. So 82, but it's going to be negative 82. So negative 2x equals negative 82. And divide by negative 2 here and here. So you have x equals 41. Then take that 41 and substitute it in here. 41 plus y equals 54. Subtract 41 from both sides. Y equals 13. So we have our same solution here. And yes, the math is more difficult, but you don't have any of the guessing and you don't have any of the difficult graphing. Elimination is another way that you can work that problem. So 2x plus 4y equals 134. So you need to line up your equations. The second equation was x plus y equals 54. And then you think, what can be done to this equation here so that one of your variables will be eliminated? You know that 2 and 1 are actually pretty close. There's a 1 in front of that variable has a coefficient of 1. So let's change the bottom equation by multiplying everything by negative 2, and then we will be able to eliminate the x variable in this. So here's our top equation again, 2x plus 4y equals 134, and then negative 2 times x is negative 2x, negative 2 times y is negative 2y, negative 2 times 54 is negative 108. You can see that 2x minus 2x, those eliminate, and then 4y minus 2y is 2y. 134 minus 108. Make that a 14 and a 6. Should be 26. 2y equals 26. Divide by 2, y equals 13. Then take that 13 and put it into x plus y equals 54. That should be 13. X plus 13 equals 54. Subtract 13 from both sides. And you get 41. X equals 41. Elimination gives you